Hi, everyone, and welcome to another episode of Pathfinder, a podcast by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and my guest today is Ray Allensworth, Spacecraft Program Director at Firefly Aerospace. Firefly is a major launch startup based out of Austin, Texas, that also has a lunar lander division built around a core lander product called Blue Ghost. Ray helps lead the Blue Ghost program, which is due to have its first mission to the moon later this year. We unpack Ray's background, the market for lunar landers, and do a deep dive on the Blue Ghost technology. On to the show. Ray, you are the second Firefly person we've had on the show. The first was CEO Bill Weber, so it's really amazing that you're here with us today. But it's been a little bit since Bill was on the show, so maybe give us a little quick overview of what Firefly is and what you guys do.
Yeah, no, definitely tough shoes to follow. But so Firefly is an end-to-end space transportation company. So what that really means is that we launch, land, and orbit. So, our ultimate goal is to be able to take customers any place, anywhere, anytime.
And what do you do for them?
I'm the Spacecraft Program Director. So largely, I focus on the land and the orbit portion of kind of all of our portfolio of programs, largely focusing on all our civil and commercial space. So like all the commercial business, basically. Got it.
I want to focus, I know Firefly is, like you mentioned, a few different business lines, the launch vehicle business, the orbital transfer vehicle or space tug, as you might describe it, and then finally the lunar lander business. But I do want to spend most of today talking about the lunar lander business, particularly Blue Ghost. So maybe talk a little bit about what is Blue Ghost, what is the program? Give us a little bit of history, like how did it get started, and why was it a business line that Firefly was interested in?
Yeah, absolutely. So Blue Ghost is the name of our lunar lander programs. And so that started off, we won our first lunar lander contract in early 2021. And so really the CLPS initiative started a few years earlier. And so CLPS is the Commercial Lunar Payload Services. And kind of on a whim, it wasn't originally in Firefly's kind of aperture. We were like, you know what, we want to go after this and we want to be more than a launch provider. And so we ended up, we proposed a few different CLPS task orders, and then we ended up winning the 19D task order. So 19D has been around as a program since early 2021. And then since then, we've won 2 additional NASA task orders, filling up. There's 3 task orders total, but 2 lander missions comprised of those 2. And
do you know where the name Blue Ghost comes from?
Blue Ghost is a type of Firefly.
Oh, okay.
I think it's native to North Carolina. I'd say like 75% confident on that
one. So how did you end up at Firefly? I know this wasn't obviously your first space gig. You've done a few other. You were at a few other companies before that. Why space, and then how did you end up at Firefly?
Yeah. So when I left college, I went to a few of the larger aerospace companies. So I spent a little bit of time at Raytheon. I spent some time at Northrop. Just really kind of getting my feet wet in these larger companies that had a lot of really good foundations to learn from. Obviously so much history. So I spent a few years there, and then really I just wanted a couple things. One, I wanted to come back to Texas, which was nice. But 2, I really wanted to work at a smaller company. So that kind of led me to Firefly, and it was right at the time that they had won Blue Ghost. So they had all these job postings coming online. So I applied to them, and I joined the Firefly on Blue Ghost in April after our award in February of 2021. And I joined as the program deputy. So like the deputy program manager for 19D, pretty much that contract specifically. And then over the years, I've kind of finagled my way up. And so I started as the deputy, and then I was the program manager for 19D. And then as we won more contracts, I'm now the program director for all of those CLPS, or really all of the commercial contracts.
What do you, how's it like building a space company in Austin, Texas? Tell me a little bit about Austin. You wanted to come back to Austin. You went to UT, if I'm not mistaken, right?
Yeah. I went to the University of Texas, which is great. Most of my family's gone there too. So I did want to come back to Texas. It was really exciting because when I graduated college, there really weren't a ton of aerospace in Texas, but specifically in Austin. And so it was really cool to be able to see that, in 2021, there's so many more opportunities. So then developing this program, especially in spacecraft, it started off with like 5 or 6 people. And now there's like 75 people supporting the spacecraft programs. So over the last 3 years, we've seen like a huge growth, and it's cool to pull from kind of like adjacent industries in Austin to kind of pull them in and, learn something new or, apply it in kind of a different way and come work on spacecraft.
So let's take a step back. Let's talk about the moon.
Yes.
So it is. There's a lot. It's in the news a lot for a lot of different reasons.
Yeah.
But one thing that we get asked quite a bit about from actually non-space people, just people who are interested in what we're doing and what we're building at Payload, but don't have a space background, is this question of Artemis. And a lot of folks are familiar with Artemis. Our plan to return to the moon, but most don't understand why we're going back. Right. I think the question is, we've been there already. Why are we planning to go back? It's expensive. So from your perspective, as someone now helping run the Blue Ghost program, like, what is the importance of the moon?
Yeah. So the moon is really interesting. So the importance of the moon. So you mentioned Artemis. NASA has, the Artemis program and this kind of greater plan of like moon to Mars. And so the moon is particularly interesting because it's close. So it's a great place to go and to learn, and I, in a lot of ways, relearn. There haven't been humans on the moon since I think it was 1972. And so it's basically this, very near planetary body that we can go and treat it like a sandbox. We can go and basically relearn how to exist in space and create a sustainable presence out, basically outside of the Earth, with the ultimate goal of being multiplanetary and living on Mars. And so, going to the moon is just this really great opportunity to kind of, easily, and I say easily with air quotes, go and learn how to, exist, on different planets.
Have you, is there any sort of internal dialogue within Firefly about sort of the national security interest in the moon, right? So if you kind of go back to the Apollo era, some folks would say that one of the main reasons why we got to the moon as quickly as we did is because we were politically coordinated around a common, call it adversary, right? Which at the time were the Soviets, and we wanted to make sure we got to the moon before they did. Now, some would argue that we are seeing a very similar dynamic with China today, and just this past weekend, China did land for a fourth successful time. So there's that sort of competition brewing in a pretty meaningful way all over again. So is that something that's discussed or talked about within the company?
Yeah, I mean, it's definitely something we're aware of, and we talk to people about it, especially different customers. We have a commercial branch within the spacecraft department. We also have kind of more of our government and DoD programs, but it's definitely something we're aware of. As you mentioned, China just recently landed, another time. In some ways, they're kind of ahead of us. They've landed multiple times. They're doing things like sample return, and so that is kind of in the back of everyone's mind and things that's regularly discussed both inside the company, but also when we're going to talk to customers, including NASA.
Is there a viable economic reason for companies to be building products and services for the moon?
Yeah, I'd say so. There's a lot of on the moon, there's just a lot of untapped resources. And so that creates a lot of opportunities for all sorts of applications. You can go and, collect material there and bring it back to Earth in a more affordable way. Or you can use the moon, to accomplish other goals. Mission 2, I know we'll probably talk about it in more detail. We're using the far side of the moon for that mission because it's silent. And so in that case, the moon has a different purpose where maybe you're not trying to get a resource from it, but you're trying to use it to have a radio quiet zone to then go explore further into space. So there's a really wide variety of applications, the economic reasons to going back to the moon.
So you're kind of laying the stake on the ground and saying that lunar landers are a business and there is a market for lunar landers.
Yeah, absolutely. And I think what's really exciting is that we're starting to really see it come to fruition. And it's cool to see it even from mission 1 to mission 2. So mission 1, we got awarded 3 years ago. And then mission 2, we got awarded a year ago. And just even the traction and getting additional payloads, in addition to the NASA payloads on those landers and orbiting vehicles, has significantly grown even over 3 years. So, if you start looking at 5 or 10 years, there's a lot of opportunity.
And what are those customers look like in your mind? We're currently, the customers today, and then how do you see that demand evolving over the next, call it 10 years?
Yeah. So the customers right now, I do think they're largely focused on like science, data, technology, kind of individual science payloads that are each looking to learn something different. And so you see it on like a lot of the NASA CLPS payloads. A lot of them come from different NASA centers like Goddard or Kennedy. And then some of them are also partnerships with international space agencies. So we have the Italian Space Agency, we have the European Space Agency, but it's a lot of like government backed programs to basically relearn or initially go to the moon. But I do think over time, you're going to see more and more commercial and it gets more into like resource utilization. How can I go to the moon and bring back a particular material or helium or, fill in blank here. And then I think once, we're really, running, we've learned how to walk, we're now being productive on the lunar surface. And then it's probably going to turn into, 20, 30 years down the line, like how can we have fun? Like what does tourism look like in a real way,
Sure.
Yeah.
So what is, we've mentioned it a bunch of times. I know you defined it, CLPS, the Commercial Lunar Payload Services Program. Why did NASA start that program? What was the main kind of point behind it?
Yeah, so I think there's really a couple. First off, we are a precursor to Artemis, and it's Artemis is obviously human rated, but we're relearning how to go to the moon and how to send science or cargo, for example. So we are related to that program in that way. But it's also the first letter in CLPS is commercial, and so one of their goals is to really foster basically pioneer the commercial lunar market. Which has been really exciting. It's kind of a different construct than what NASA's typically used to doing. But it also opens up a lot of opportunity in that the costs are a lot different. And so, you can send a lander to the moon for $100 million instead of $100 billion. And I think that's what's really important, to have like a sustainable space exploration program is that it remains affordable because that was one of the problems in the Apollo era. And one of the reasons that it ended is that you didn't really have the political backing or excitement anymore, and it was extremely expensive. So I think CLPS comes to like answer some of those problems so that we can, keep this program going for a while.
What do you think is the most promising commercial opportunity on the moon? If you were to just pick one and say like, this is the one that's going to like make companies a lot of money.
I do think that like resource utilization, like once we find a way to tap into the resources of the moon and make it productive for us back on Earth, like, I think that's where a lot of the money is.
Right.
I'd say like very far down the line, maybe instead of going to Italy, you take the family to the moon. But I don't know that that's like the most practical or near term goal. But yeah, I think the resources, not just on the lunar surface, but underneath the surface. And, there's an opportunity.
It's very interesting you mentioned tourism because I just feel like there's been so much. This episode has been fortuitously timed because there's been so many interesting pieces of news that just came out, especially like Yusaka Maezawa just canceling his the Starship flight. I actually personally think to kind of to state the obvious, I think most people think that it had nothing to do with the schedule. I think it just cost. I think Maezawa is having his own financial difficulties is what it sounds like, but. It was, I actually ended up, I spent a bit of time this weekend reading all these like reactions from the potential crew members of Dear Moon. And it was very sad. It was like a lot of people who were like, I really thought this was going to happen. I'm shocked. I'm sad. I'm saddened by the whole thing. I don't know if I'll ever get to go back. And what did you have any initial reactions when you saw that news?
Yeah, no, I kind of did the same where I started looking into, okay, who was planning to go? I think the first one I read was like Everyday Astronauts Response. And it is sad because like, I feel like in a lot of ways, the moon is like so aspirational and beautiful. And it's kind of like, like it's exciting, to just have this idea of like, oh, maybe I'll get to go there someday. And so like, it was kind of heartbreaking for those people to not be able to go. But I can't say it was the most unexpected thing to happen. Because like you said, once it hits a certain price, you have to do an ROI, and sometimes people's feelings are not necessarily taken into account for that.
Sure. Well, okay. We've landed on the moon, I think if my count is right, 6 times. Apollo 11, 12, 14, 15, 16, and 17. I think those are the 6 human landings. We've had over 20 successful robotic landings. Yet at the same time, we've had a lot of failures recently. There's been a lot of companies and nations that have not been able to land. You had Astrobotic earlier this year. They had an issue. Intuitive landed, but on its side. So kind of partial success. Why is it so hard to state? I mean, maybe this is a very obvious question, but like we've done it a bunch of times. We've done it a ton of times, I'd say, right? Between human and robotic. Why is it still so hard?
Yeah. So, I mean, I think what a lot of people kind of overlook is just how extreme the environments are once you leave Earth. And that's if you survive the launch environment, which I think is now becoming basically a solved problem. The dynamic environments in a fairing are generally well understood now. And so, okay, say you overcome the incredibly hard trip to get out of Earth. Now you're in orbit. And now you're faced with these extreme temperatures. It's extremely hot. It's extremely cold. There's radiation. And that's all while you're in orbit. And then say, go even further and say, now I want to land something on the moon. And it's this place with basically no gravity. And it's covered in this regolith that's extremely sharp. It's extremely fine. It gets into everything. It breaks everything. It covers your optics. And these are all environments that are extremely hard to test while you're on Earth. There's very few spacecraft, particularly commercial, that you can take your whole spacecraft and go test it exactly as it's going to see the environments in that order, launch through landing. And so, there's only so much data there. There's probably just that as many data points as you mentioned for ever achieving that. And so it's just a really hard challenge to solve.
No, I say it somewhat facetiously. I mean, we've launched rockets so many times, and it's still
they still blow up. Yeah, and
sometimes they still blow up. Exactly. Talk a little bit about how the Blue Ghost architecture differs from the existing lunar landers. And I know there's a number. I'm not asking you to compare them to every single one, but just like even comparing it to like an Intuitive or an Astrobotic or like China's recent lander, like how does it differ? What are sort of like I don't know, kind of strengths, weaknesses? How would you kind of think about that?
Yeah, so I think our architecture, I think it really highlights like our strengths as a company. And so some of those things, like I think just visually when you look at it, I think one of the first things you'll notice about our lander is that it's a little bit shorter and it's a little bit wider. And so, landing softly and upright is like number one. And that's really reflected in our structural architecture and that. And then, you look further in our carbon composite technologies, basically our whole primary structure uses that. So we're extremely light, but we're really strong. And that includes our foot pads. You'll look on our lander, and I think another difference you'll see is that our foot pads are a lot larger and they're a lot more round. And we ship at an angle. And so that's also very intentionally done to make sure that when we land, we're less susceptible to say like horizontal velocity or maybe catching a foot on a rock or something like that. And so I think that's the most obvious difference. But I think one of our biggest advantages is that, we're not just a system integrator at Firefly, is that we really control the design of every single subsystem pretty much all the way from component through, manufacturing, integration, and test. And so we're able to really develop these subsystems and these technologies that, they should be really effective in these environments. And so, being able to create, I don't want to say like unique because they're also like repeatable. And that's one of the goals is to make every dollar we spend really productive. And so we're not just designing something one time, but it's able to really meet the requirements of landing on the moon.
What are, you've talked a little bit about the pros, but like having like a shorter, wider frame, right, around a lander, how does that, what are the downsides of having that type of structure versus like, I don't know, call it an Intuitive, which looks a little bit taller and skinnier for that's my engineering talk. Yeah.
Like what are the downsides? I'd say, one of the things we've seen is, sometimes there's less clearance on the ground. So, some payloads, depending volumetrically where you're at, maybe it might be harder to accommodate you on the bottom deck. We have seen that a couple times. We've talked about how to fix that in the future, or, kind of what mechanism is maybe needed to accommodate those kind of payloads. So inevitably, that's the first one. It's kind of the space between the ground and your bottom deck. But otherwise, I don't know that there's like pros and cons. It's really just to kind of accommodate different scenarios and payloads.
Sure. So what technical milestones has the program achieved so far that you're allowed to share?
Yeah. So Blue Ghost Mission 1 is pretty mature. So it's almost fully integrated at this point. We really just have our solar panels and our legs to put on, and we pretty much, and our MLI, so that outer thermal blankets. And a lot of those we really don't put on until the very end because it blocks the interior of the lander to get in there for, final integration and test. And so we're prepping right now for environmental tests. So that'll be our next big milestone. And then we'll ship out to environmental testing. We have we're using JPL. They're partnering with us to do that environmental testing. And then after that, it really just gets into, pre-ship review, launch readiness review, and then launch. So we're right at the end.
How large is the Blue Ghost team?
The Blue Ghost team right now, there's about 75 people that support Blue Ghost. So we're about 10% of the company-ish. And then give or take, we have a couple contractors as well.
What are so you talked a little bit about a few of them. Like what are some of the most important challenges for, let's call it, just stick to mission 1. For example, like surviving the night. I know that's one thing that people talk a lot about, especially in the lunar lander world. Talk about like what are the most one or two most important challenges that you guys are solving for, and how is the lander solving for those challenges?
Yeah. So some of the things we're solving for. Yeah. I mean, you mentioned survive the night. That's actually kind of an adder for us. So I'd say leading up to that, I think the first big milestone for the lander is, that initial power up and that initial priming the propulsion system. That'll be a really big one. And then, obviously landing with an ability to avoid hazards, landing softly, and then operating. So then it becomes a comms activity. And then, this actually isn't in our requirements for mission 1, but we're doing a couple extra things to kind of prep us for future development and for future missions. And that goes back to what you mentioned is the survive the night. And so one of the things that mission 1 is doing is that, so we land, let me back up. We land at the very beginning of the lunar day. So at sunrise on the moon, and we'll operate for 1 lunar day, which is about 14 Earth days. And then that's effectively the end of our mission. And then we're going to extend operations a couple hours into the lunar night. And so that's kind of that first step into learning how to survive the night, which was really exciting. And then we are going to try to turn back on after the lunar night. We are not expected to turn back on. But again, we want to just try to see, what data we can collect there, if any.
And is this all solar powered?
Yeah, so we've got solar panels, and then we also have batteries the batteries are pretty cool. They're an in-house developed battery. And it's a very similar battery that flies on Alpha, and it's the same battery that flies on all of our orbiting spacecraft as well. So that's an in-house design. But yeah, between the batteries and the solar panels, that's how we power the lander.
So I know RPS, or radio isotope power systems, have been used in previous moon missions, especially during Apollo. Obviously, that's using nuclear power. Is that something that is on your radar as you think about powering future lunar landers?
So it's something we've talked about. It's not something we're actively pursuing right now. That is one of the options when you're looking at surviving the night. I think there's a couple barriers there, but one of the barriers is just pathfinding the paperwork to using that in a commercial setting. And so, it'll be really interesting to see kind of which direction Survive the Night goes and where that technology goes. If we stick with batteries and stuff like that, or if that becomes the primary path. But so we've talked about it, but we're not really actively working on it right now.
So you mentioned earlier that one of the big challenges of Lunar is, or doing anything on the moon, is the fact that you can't really test and operate. Right, on the moon, you have to go there and figure it out, right, or see how it all works in that environment for the first time. So how are you thinking? How does Firefly test for the lunar environment and try to get as close as possible to what it's going to actually be like?
Yeah, so we do focus a lot, both at the component level and the spacecraft level, to kind of test in the order of the environments that hardware might see it. So, all of our components and subsystems will basically go through a pretty rigorous dev qualification and ATP campaign. And so, it'll go through vibe and shock and acoustic, and then, thermal vacuum, EMI, EMC. We've done radiation testing on certain electronic components. So that is all kind of at the component level. And then we'll do basically the same thing at the spacecraft level. Again, go back through the dynamic, all that. And that's where we're partnering with JPL. And then there's certain things that are just really hard to test on Earth. And that's something like landing. How do you test landing on the moon, but on Earth? You'd basically need a massive vacuum chamber covered in regolith. I mean, it would just be it basically doesn't exist. And so one of the components of that is just landing. So one of the activities we did is a bunch of drop testing. And so we basically built a flight leg with a flight foot pad, all of that. And we loaded it up on what is basically equivalent to a gym bar, like a weight rack bar, and dropped the foot on concrete, on rocks, on lunar regolith simulant, basically 100 times at a bunch of different angles and a bunch of different weights. We've done analysis with that to say, hey, what if we land on 2 legs? What if we land on 3 legs? What if we land at an angle? So that, for landing, that's kind of as good as we can get to test out, the structure of the leg, but also kind of, we have sensors on the foot pad as well. So that was kind of a fun one to do. The guys were out in the parking lot in like hazmat suits testing because we had the regolith, which is extremely carcinogenic. So that was an interesting test campaign.
How are you testing propulsion?
Yeah, so prop will test at the component level. So those will see propellant in a vacuum. So, like our main engine does that, all of our RCS thrusters. So those will go through like a full qual, or have gone through qual, and then ATP testing, in a vacuum chamber with propellant. But that'll happen at the component level. Otherwise, they really won't see propellant until it's in orbit again.
So I'm gonna ask a dumb question. So you load up Blue Ghost into Falcon 9, which is what you're using, right? Falcon 9, later this year. And, launches. At what point are you no longer doing anything? Meaning like it's sort of it's like on its own, meaning like it's autonomously navigating and landing. Like walk me through, like, what does that look like?
Yeah. So it'll be after a little while. So we will, we say goodbye. It launches powered off, and then it'll power on in orbit. We're doing a couple Earth orbits first. And so that's really our opportunity to talk to the lander, check it out. If we need to, upload something, make corrections, recycle anything, we have Earth orbit to do that. And then we'll do critical maneuver into lunar orbit. So then we'll be in lunar orbit for a minute. And then basically the autonomous portion is landing. And so basically that critical maneuver for the lander to, land, that is autonomous. And that's when you kind of take your hands off for a moment. You're like, all right, Godspeed. And then, once it lands, then we also operate. So we'll basically put our hands back on it, and we'll do operations on the lunar surface before ultimately, we hit the lunar night and the lander will power down, and then it'll really be over.
I want to spend a little bit of time talking about how long each of those kind of phases takes. But before we get into that, okay, so we're talking about a lot of cool things, fun things, and also challenging things. Like what keeps you up at night regarding the risks associated with this mission? Like the mission is coming up. We're June, right? It's not that far away.
It's very near.
It's very near. Like, how are you thinking about, between now and the end of the year when you guys are going to be attempting this? Yeah.
So it's something that me and the chief engineer talk about all the time. We worry about propulsion. It's obviously scary. The first time we prime the propulsion system in space, like that will be a scary moment. And, but we're doing everything right now we can to be comfortable, feel comfortable, feel prepared. Really, what keeps me up at night is like, what am I not thinking about? Like, what am I going to look back on and be like, 2020 vision, that was so obvious. It was so right in front of us. And so that's what kind of, I think, annoys me the most is like, okay, Rachel, like, what are you not thinking about? Which can be kind of annoying. But honestly, like, I think the team, over the last 3 years, we've spent so much time, testing each component and getting familiar with the spacecraft. The team in the clean room has been effectively testing that lander near 24/7 for months. And so, it gives a lot of confidence that you understand how the lander is going to behave, and what it doesn't like, and how to deal with it. So that's kind of comforting. But
So for mission one, so we know what Firefly's objectives are, right? Get the payload safely on the moon and hopefully survive the night and show some data afterwards, right? So we have some, we as the audience understand that pretty well. I'd say, like, what are the key objectives of the customers? So like NASA and anyone else who's on mission one, and we don't need to go through every single one, but like, what are they looking to achieve?
Yeah, so a lot of the payloads, well, each of the payloads kind of has their own science objective. And, surviving the night is just a bonus. All of their core objectives will happen during that first lunar day. And so, it varies. The first off is the science objectives. A lot of them are studying the regolith. Some of them are looking back at Earth to get information. So one of them is like kind of like GPS for the moon. But then I think there's kind of secondary objectives. Like one of the payloads, it's the first Italian hardware that will be on the lunar surface, and so that is a lot of pride for them. And so besides their science objectives, that's also like, that's a huge win for the Italian Space Agency. And so we're kind of helping also, help, them achieve that goal. But I mean, really, you just operate as expected and get the data, send it back to the payloads, and, hopefully everyone's happy.
So you mentioned something that's interesting, which is like this idea of national pride and having, like, for example, Italian hardware, or maybe a Gucci wallet or something up there for the first time. But
on there,
yeah. But kidding aside, I think it's an interesting comment you made, because I had on our last episode we had VAST, and we had Jed, Caleb, and Max Hout from VAST talking about space stations and the demand for space stations and who's going to use it. And I think there is one part of the demand cycle I don't think people spend nearly as much time or don't give enough credit to, which is this idea of national pride, right? Which is like, we had back in the 60s and 70s in the Apollo era, there was only 2 space programs. There was only the US and the Soviets. And today there's nearly 80 space programs. And they don't have nearly as much of a budget that the US does, that China does, or that Russia does. But now, with a fraction of the dollars that were used in the past, you could actually get hardware from your country to another planetary body, which is extremely exciting and extremely cool for a lot of nations. And, that stuff matters. That type of exploratory mission and the ability to say, like, yeah, our country did that is worth a lot. And by the way, that's another big market to go after.
No, it's huge. We mentioned the Italian Space Agency, but Mission 2 has the European Space Agency. And, we're getting a lot of traction from, certain countries, across Europe and the Middle East and Australia, all wanting to do the same thing of like, hey, can you take my payload? I can't maybe build an entire lander, but hey, you have a ride. Can we join? And it's really cool to talk to all of those customers and just, get it started.
So Firefly's won 2 CLPS missions so far, right? Which I know this is public, worth about $200 million total between the 2, right? So we talked about mission 1. What is the significance of mission 2? Let's kind of look ahead of November, December, and say, like, all right, what comes next? What does the second mission look like?
Yeah, I think mission 2 is really, really interesting because it's a combination of a couple different things. So mission 1 is a lander. And then mission 2 is where we start combining some of our spacecraft. And so mission 2 is a transfer stage, which is our Electra Dark. So it's an orbiting spacecraft. And then it's a DPAF, so a payload attachment fixture, and then the lander on top. So we kind of affectionately call it the stack. And so, but what I think it really embodies is, really productive dollars spent on kind of these Lego kit of these building blocks of components. So, we're taking a lot of what we used on mission 1, a lot of the same composites and avionics and batteries and fluid systems and radios. And we're now applying it to mission 2 and saying, hey, from those Legos, from those building blocks, we're going to build a transfer stage that's going to get the stack into lunar orbit. And then, we have a lander that's almost copy and paste. So again, you're not spending the NRE on redesigning a lander. We have this lander and we're able to just kind of adjust where the payloads are sitting. Mission 1 is 10 small payloads and mission 2 is 3 large payloads. So with very little NRE, we're able to adapt that lander design. So, the lander will go off, it'll go to the far side. And I think that particular payload is really cool because I think I mentioned it earlier, the moon can be used for a lot of different purposes. And so on that particular one, the lander's landing on the far side so that it's effectively in a radio quiet zone. It's not hearing any of the noise from Earth. And so it's looking out to basically learn about the history of the universe, which is really, really cool. And so it's landing very similar to where the Chinese lander just landed, actually. So that payload in particular is really special. And then that transfer stage is, again, really important for the company because it didn't just get us into lunar orbit. It is now a service. And it's basically a demo of a comms network around the moon. So it'll be a comms payload around the moon for up to 5 years. And so there's a lot of different applications for that particular spacecraft.
So, okay, I want to.
Sorry, that was a lot.
No. No, that's great. So the Chinese mission that just landed on the moon, from my understanding, what they're attempting to do with that mission is to return lunar regolith samples back to Earth, and it's the first samples from the far side of the moon that we are going to be returning, right? So they landed the first lander on the moon on the far side, and they're trying to return the first samples from the far side of the moon. Is Mission 2 the first commercial, or actually, forget about commercial? Is it the first U.S. lander mission to the far side of the moon?
Yeah, I'm pretty sure.
That's pretty exciting.
I feel stupid if I'm wrong, but I'm pretty confident.
Yeah, no, I think you're right. Assuming, I don't know what the other commercial schedules are and where they're planning to land, but if that's the case, then that's pretty exciting.
It'll be huge. Yeah. So yeah, very, very excited. Yeah. Mission 1, our goal is let's be the first U.S. commercial, to land upright, full success, be able to complete our full mission. And then Mission 2, let's be the first U.S. commercial to the far side of the moon.
What's next after CLPS?
Yeah. So I think that's a fun question because there's a lot of, we talked about earlier, the growth even from Mission 1 to Mission 2 over the last 3 years in the commercial market. So we started to talk about, okay, what does it look like to just have a fully commercial mission? Instead of kind of using CLPS payloads, now we have this kind of commercial pipeline that we're fostering. Can we create a fully commercial opportunity ourselves, have a Firefly lander and, aggregate these payloads and take them to the moon? So we've started talking about, what does a fully commercial mission look like? But then there's also a lot of other customers, there's other government customers that also have interest in the moon, whether it to be sending comms payloads or smaller payloads. And then you kind of look further and scaling up. And what does it look like to send a lot of several metric tons of cargo and science experiments to the moon? And so that's kind of what comes next, I think.
Do you think Blue Ghost can stand independently as a profitable business line for Firefly? Sorry, that one came out of nowhere. But as you're talking about this big vision, I'm like, okay, this all sounds great, but
yeah,
how big of a driver of dollars to the bottom line do you think this is going to be?
Yeah, so I'm a big believer in it, in the line being profitable and a really big revenue generator for the company. And so, if we looked at Mission 1 in a bubble, for example, and so Mission 1 is going to effectively be break even, which is really exciting for a first mission. And so if you just look at that mission, you can pretty much off the top say 40% goes to your launch vehicle. Okay. And then you have the 60%, and it's basically 60% labor and 40% material. And this is just your cash out. And so, Mission 1, it's how do we make these dollars most productively spent so that, hopefully in the future, we don't have to spend as much. We have a repeatable design that we don't have to go back through qualification, so that Mission 2 is then we spend a little bit less money on those things. And then you balance that with what can we bring in? And so Mission 1, there's not a significant commercial presence. But Mission 2, that's actually not true. The lander, for example, is fully sold out. And there's a couple of payloads that we haven't announced yet. So not only are we driving costs down, but we're also now bringing revenue in with additional customers. And so there's definitely a very large path to being profitable as a standalone item.
Right. And even the launch cost, right? 40% goes to, you would assume, and I'm going to assume that, Firefly being a launch business intends on launching its own landers to the moon eventually, right? Especially once you guys have your next generation launch vehicle up and running. But it's probably safe to assume that even that 40% launch cost is going to come down, even if you weren't using your own vehicles, right? Just based on where, what folks are
Yeah.
predicting.
That's ultimately the goal, is that, it becomes more available, more repeatable, and then, kind of costs go down with that. So yeah, the goal is that regardless, it goes down.
What sort of role do you see the company in the broader context of the Artemis program, right? The Artemis program, obviously we have every intention, and we will land humans back on the moon. And, it's an exciting, most of us, you and I included, weren't alive the last time we had people on the moon, right? And we're about to see that in this decade. So how do you see the company within the sort of broader context of all that, specifically the Artemis program?
Yeah, I think we're really well suited to support that program and its greater mission objectives. It's not currently like in our roadmap to say like support human rated programs, but there's a lot of other things that you need to support those programs. And so, basically the foundation that we're building with the Blue Ghost landers and the Electra spacecraft is that we're able to send repeatable and reliable cargo, for example, or science, wherever you need it to go. If you need it to go equatorial or South Pole or far side, or hey, maybe to support the Artemis missions, you need more antennas in lunar orbit. So we can use these electric vehicles and set up a comms network for you. And then we can also apply it, ultimately, it's moon to Mars. The Electra spacecraft in particular is really cool because it does have enough delta V, and we can reconfigure those Lego kit to not just go to the moon, but turn it and go further and go to Mars. And so I think we'll continue to grow alongside Artemis to support that program pretty well.
What about sample return? So eventually having Blue Ghost, dock with an orbiting Elytra and coming back to Earth. Is that part of the plan?
Yeah, absolutely. That's definitely in the nearer term. That's like less than 3 years. That's much more immediate. Is sample return and survive the night are kind of 1 and 2. And then those technologies can basically get applied to, wherever your destination might be. Obviously Mars is a little different, but yeah.
So you and I have talked about this outside of this podcast, and I want to ask you so that you talk about it publicly. But okay, so we saw Intuitive; they launched to the moon earlier this year. There was an enormous amount of media around what was happening around the company, around the people involved in the company, around mission control, everything. Right? I have no doubt that we're going to see that again later this year. Are you guys ready for the coming press bomb that's probably going to hit you soon?
Yeah, no, I think emotionally we're preparing. I'm a little nervous, but we're spending not a lot of time. A couple of us, we're really partnering with our marketing team. We're partnering with NASA a lot to have a really thorough comms plan, and then also just basically mentally prepare ourselves for, any scenario most likely. And what we most want is a highly successful mission in which we will have, significant press and interest. But it is a little bit nerve-wracking, but it's pretty exciting.
Okay. So I have a few Ray specific questions to kind of close this out. So my first is, I think a relatively easy one, which is like, what's one experience that you've had in your career, particularly at Firefly, where you said to yourself, like, hey, like, I'm in the right field? Like, it just made you realize that you were definitely in the right role, doing exactly what you wanted to be doing.
Yeah. I like that question. I think one moment where I really realized that, like, I'm in the right spot is, I guess it's not necessarily one moment. It's just like a series of moments over time where it's like, no matter kind of what the challenge of the day might be, like it's like you care so much about the program you're working on and the people that you're standing next to that, like, it just makes you want to solve the problem, and you want to work late, and you want to, like, give it your 100%. And that, you don't always experience that at work, and certainly in, like, previous jobs I have where it's like, okay, I went into work and now I'm going to go home and I won't think about it again until 8 a.m. And that's actually, like, really fulfilling to be able to say, like, wow, like, I love this team and this program. And, like, there's nothing that's going to prevent me from, like, staying here or coming in early or, doing whatever I have to do to support the program and the people on it. And so that's really where you realize like, oh, I'm definitely in the right spot. Like, this is what brings me joy. This is what motivates me. This is what inspires me. And so, no matter what happens, good or bad, and there's a lot of bad that happens. It's really hard. These programs are really complicated. It's like, you're never going to have the perfect week, but you always want to come in the next day.
So I have a surprise. So 10 minutes before we started recording, so NASA gave me a call and they said, hey, Ray and the Blue Ghost team have done such a great job with our first CLPS mission. We want to give them 10 pounds of payload to send whatever they want. So you can send whatever you want. You have 10 pounds. I don't know what that is in kilograms. You can probably, if you're currently in the kilogram mindset, but 10 pounds of secret payload you get to sneak into Blue Ghost. Like, what are you sending to the moon? Oh
my God, I get to send anything. Yeah. Oh my God. I might send one of my Beanie Babies from when I was a kid or so one thing that we are looking to add is basically a plaque of everyone's names that supported the mission. And so that is something that I love because, it'll be there forever, and it's kind of like, it's like a piece of all of our souls is on that lander, and our names are on it. And so that payload, that addition, I'm really excited about to be able to send that so that we're kind of forever represented on this thing that we've worked on for so long.
That's very cool. If you weren't at Firefly, what would you be doing?
Oh God, I have no idea.
That's a good answer. That means that you're so focused that you don't have headspace for anything else.
Yeah, to ask me like after like January. And then we'll see. Yeah.
Okay. My last question is, so you're in Austin, you're in Texas. Where's your favorite place to eat in Austin?
Oh,
do you have any recs? I get that question all the time. So
yeah?
I want to throw it back to you and
maybe
give me some ideas.
Okay, this is probably a hot take, but I think some of the best barbecue is Interstellar Barbecue, and that's in City Park. So that's a big one because I didn't say Terry Black's or, and then I really like Canje, Canje. So next time you're in town, give that one a shot. That's a good one.
That's a Caribbean place on the east side.
It's good.
Yeah, that's a really good one. Awesome. Well, thanks, Ray, so much for being on the show. It was great to hear. And I hope we can get an interview with you after you land on the moon. I'm sure it's going to be impossible. You're going to have like 50 different media outlets. But just remember, Payload had the first interview.
Yeah.
So thanks so much for being on the show and looking forward to having you back.
Thanks.